welcome to AP Statistics Chapter 9. Today we will be dealing with regressions and residuals, and some important details we'll be dealing with are high leverage points with small residuals, outliers that aren't high leverage points, and influential points.
High leverage points with small residuals. A person who is really tall and weighs a lot may fit the overall pattern perfectly. The slope and intercept may be largely unaffected by that point. Such a point, however, will increase the value of the correlation, possibly misleading you into believing that the model is stronger than the rest of the data may warrant. Of course, it is best to check that the model for the other points is the same. If the other points don't determine a clear model, one extreme point can completely dictate the model. Be wary of overstating your case on the strength of one point. Outliers that aren't high leverage points but still show up with larger residuals may not affect the slope much but are clearly not consistent with the pattern seen in the other points. They often show the intercept. Never throw them away without just case. Sometimes we know or strongly suspect that a datum might be inappropriate to use. Mistakes in measurement, an individual known to be somehow different from the rest of the group, etc. However, it's not defensible to pare away anomalous measurements just to strengthen a model. Most troublesome are influential points. These are high leverage points that aren't consistent with the model that describes the other points. These distort the model and may mislead us about the underlying relationship between the variables. They are hardest to detect. Influential points may have very small residuals precisely because they are influential. A point that is an outlier on the x direction may exert so much leverage that it pulls the regression line towards it. We need to look at the scatter plot, covering up a point or two at a time to see if our perception of that pattern changes. Go ahead and pause the video and take a minute to decide if each influential point has high or low leverage and a small or large residual. Alright, so looking at A, the influential point would have low leverage because it only pulls the line of best fit up a little bit, and a smaller residual because it's not as far from the line of best fit as some other points might be. Looking at B, it's going to have a higher leverage because it's a little bit further away from the other data points, so it's going to pull the line of best fit a little more, and it's going to have a larger residual because it's even further from the line of best fit. And looking at C, the influential point down there, it's going to have high leverage because it pulls the line of best fit down, and it's going to have a large residual because it's very far from the line of best fit. So up next, we're going to learn how to use your calculator to create a residual plot. Now, I can't find my graphing calculator, so you guys are going to have to kind of work it out as a class and see if you all get the same thing, because it's the end of the school year and I haven't had much of a desire to use it, therefore I have misplaced it. But anyway, first, you'll load data into list under stats, edit. To view your data, you'll hit second y equals plot 1 on scatter plot. Your x list will be L1, your y list will be L2. You'll want to hit zoom stat to get the best view of it. To paste your regression equation into y equals, first go to the home screen. Stat, calc, linear regression, a plus bx, L1, L2, vars, y vars, function y1, enter. Now examine the graph. Yippee! It's there. Residual plot, x hat versus residual, L3 residual, second stat, names, residual, enter. Second, y equals plot 1 on scatter plot, xlist y1, ylist, residual, or L3, and then finish it off by hitting zoom 9. Let's practice making a residual plot. Load the following data for tuition costs at Arizona State University. Begin the first year as year 0. Go ahead and pause the video to load your data and work it out. While looking at a residual, you want to know if it would be reasonable to use a linear regression for it. Well, in order to use a linear regression, the residual must be linear. A good way to tell if a residual is linear or not is to look to see if it has any obvious patterns in the data points. So, a plot of the residuals versus the fitted values for record-breaking times of female marathon runners for the years 1996 to 2003 is below. Based on this residual plot, does it seem reasonable to use a linear regression for this model? While looking at this residual, I don't see any obvious patterns, therefore I would say that it is linear, and therefore it would be reasonable to use a linear regression. Alright, one more problem for you guys. Here's a scatter plot of weight versus height for students in an introductory statistics class. The men are coded as 1 and appear as circles in the scatter plot. The women are coded as 2 and appear as squares in the scatter plot. Do you think there is a clear pattern? Describe the association between height and weight. Weight and height. I will pause the video on the scatter plot and you guys can answer the question. So for A, I would say that both men and women have a strong linear positive association between a person's height and their weight. Therefore, as a person's height increases, so does their weight. Now, once again, pause the video and comment on any differences you see between men and women in the plot. So, comment on any differences you see between men and women in the plot. On average, men both are taller and weigh more than women do. They also have some influential points between a weight of 250 to 300 pounds. The women's data has a stronger correlation with lower weight and height averages and with less influential points. Alright, finally C. Do you think a linear model from the set of all data could accurately predict the weight of a student with a height of 70 inches? Explain. I'll pause the video again and you can work it out. Okay, yes. 70 inches would be right around the average for the individual heights. Therefore, it would accurately predict the weight of a student of 70 inches. However, if the student's height was 80 plus inches, we would then be extrapolating by saying that we could accurately predict it, because we do not have enough data at that height on.